Physics, especially circuits, is high yield on the MCAT because it has applications to biosystems such as cardiovascular modeling. As such, it's important to understand the derivations of Kirchhoff's voltage laws. So suppose we have this setup right here where we have 5 ohms and 10 ohms in series right here, which means that they're followed right after each other. And one way you can remember that is like, think of a television series. You don't watch the episodes at the same time, you watch them one after the other, and then you have 2 and 3 in parallel right here. So I already drew up a current I that we're going to calculate for, and now there's going to be 2 ways that we do this. So number 1, we're going to calculate this one first by deriving the laws first. So if we know V equals IR, and we know that voltage on both sides will be the same, and voltage prime on both sides will be the same. So what we can do is voltage equals I R1. Oh, that's right. You can start off with and then we can isolate V is the same, so 1 over R1 plus 1 over R2. We move this to the other side because we're solving for current to begin with. That's what you usually calculate. Usually they give us the voltage. So what we'll do is do I over V equals 1 over R1 plus 1 over R2. But we know that the whole circuit, for the whole circuit, this also applies. Which means that what we can do is we can go back and say over V equals 1 over R for the whole thing if we rearrange this. So we can replace this with 1 over RT equals 1 2. Means that 1 over 2 plus 1 over 3 equals 1 over R. And then one way we could solve for this is if you know the trick 1 over A plus 1 over B. I know pre-meds love to memorize, so I'll give you a quick trick right here. Plus B over B. You can use this formula to solve to be 5 6 equals 1 over R T. And then that means 6/5. 6/5 equals R for that certain, not one set of resistors right here. So when we rearrange, we're having 6/5 plus 5 plus 10 ohms. And this is going to be still epsilon. I haven't picked a value for that. We can just leave it like that. Now I'm going to derive the next set of laws from Kirchhoff's circuit laws, which states that the sum of voltage across the entire circuit must be 0. If we know that it's going this way, we're going to start off by gaining voltage plus epsilon minus, we're losing voltage, minus 5 minus 10 minus 6/5 equals 0. Epsilon equals 5 plus 10. Oh, whoopsies, forgot. I multiply everything by I. It's easy to make mistakes. 5I plus 10I plus 6/5. This works out to be 15, and this is 1 1/5, so it's going to be 16 1/5. I is going to be epsilon in a fifth. Works out to be 16 times, I'd say 8 times 5 is 40 times 2 is 81/5, I think. So it's 5 epsilon. We'll check that. Yeah, 81. Yeah, awesome, cool. I just want to show you right here, I have a circuit on everycircuit.com. As you can see, you can drag and drop. I have a 20 ohm resistor followed by another 20 ohm resistor, the ground, and a 4 volt DC current and an ammeter. So I can simulate what the resistance would look like and the current and so on.